Alright. Hey everybody, Rick here. Welcome once again to the Engine Laboratory. Yeah, kind of before I start cleaning up here and going upstairs, I'll show you a couple things I got going here. I got this circuit from last time, this little high frequency circuit here, and I put a different coil on here. This one runs at a higher frequency, it's about 3.2 megahertz. So it's kind of true. I do need to get a coil that's roughly, I'd say, between 4 and 5 megahertz. 5 megahertz would be optimal because that's what this circuit is trying to run, is a 5 megahertz coil. But I did notice that, from switching to this one, did drop down the actual current draw. So it's only drawing like maybe a couple amps, which is good. The other one was drawing excessive current. And this one's a lot better, and I can actually crank this up to, I cranked this up to 60 volts, so it was pretty good. I do apologize for my camera zooming in and out, nothing I can do about that. Just wanted to do this really quick and upload it. That's one of the reasons I like doing it on my phone, is that I can just upload it directly from the phone. So, yeah, anyway, I can crank this up to 60 volts, and it works. Everything's happy. The only thing I need to change still is this capacitor here, and I think that has to do with the high frequencies. It actually gets warm. It shouldn't be getting warm. I don't think it's because of excessive current draw. It gets warm regardless if I use the other smaller coil or this one. It doesn't matter. So yeah, if you're going to build something like this, I would suggest replacing this electrolytic cap with a film cap or something. Even maybe another ceramic, if you can get one at 10 microfarads. I doubt it. I do have 10 microfarad capacitors. They're tiny little things. I'll probably end up changing this out with a film cap, maybe a couple microfarads. I don't know if it's there for smoothing. I would assume it's just there for smoothing, because it's being on the power rails. Because then you have right in front of it a 100 nanofarad capacitor. That's probably to try to mitigate the higher frequencies going back into your power system and potentially hurting something in there. Yeah, I don't know if that's has more to do with the switch mode power supply as opposed to linear, because I'm using a linear supply, so it's not a big deal. So we'll run this first, and then I'll show you the other little project that I'm working on. And yeah, there's not very much, like the discharge isn't as crazy as like maybe my other one, but it's putting out quite a good amount of RF power, which is nice. So I'll just get it going, and that's at 10 volts. Yeah, there's no breakout, but it doesn't matter. Who cares? And you can see it getting a lot brighter. Oh, there goes the other one. We're at 30 volts. 40 volts, so there's a little bit of a streamer coming off there. And that's the highest my supply goes. It does work pretty well. I would keep it on, but I'm a bit. I don't want this capacitor to vent. I really need to replace this and get this off. And the heatsink doesn't heat up as much now, but just to prove that this does go up, I'll put it up again one more time. So yeah, close to 55 volts, whatever. And it does work. Very bright. Very nice. So just with some small modifications, yeah, this will work. I don't think I either don't have the right gauge wire or the right former to do this. I'd have to kind of dig around with this some more, and obviously get that in build a little meter. But that's really cool. It's really nice. I don't know. I'm going to turn on the light because I'm going to go over here. So we'll work on that a little bit later. I'm going to put that on the side. So I got to clean that up so I can power this guy up. So this was the Class E coil that I had before, but this is a little bit different of a circuit, where it uses a feedback transformer coming off the. So actually, yeah, coming off the ground. I think I have. It's supposed to be one turn, and I think I have two turns on here, so I got to correct that. And I also forgot the coupling capacitor that goes from this this transformer into the circuit. So yeah, there's a feedback transformer here, I kind of wanted to try this out because eventually I'd like to switch over to these for a half bridge topology. And then there's another feedback that comes from the drain of the MOSFET, and it goes through a couple components and into pin 3 of this CD4046. So I'm not quite sure that it's a phase lock loop. I think it has to do with like the phase shift or whatnot. I gotta play with this some more because it still seems that, you know, if I'm coming too close in the contact, it throws out the resonant frequency, and that shouldn't be doing that. But I got to play with this some more. I just got done putting this together and testing it, and I'm just looking to see if my interrupter's still on. I have this on interrupt mode. You know, it's pretty simple. So you basically, if you want to interrupt it, there pin 5 that's on this chip. You'll switch. You put a little switch here. So constant wave, you'll switch pin 5 to ground, and interrupted, you switch it the other way, and the interrupt signal is coming through. I just threw on a big old 1K ohm resistor that's on here to pulse it. And it, you know, works fine. We can turn it on. Kind of, yeah. I was kind of hoping it would do that. It's kind of really interesting to see the plasma ball there doing its thing. If I move my hand, is it going to do anything? Is it going to come towards it? Maybe not. Oh. Interesting. So I just have a couple of things over there doing their thing. Nothing fancy, it's just on 24 volts from the ATX supply, so current limited. But yeah, theoretically this should go up to 50 volts. At least that's what the circuit diagram says. I don't know, I'm a bit dubious about that. I mean, the MOSFETs that are used, I'm using a, I think it's a 740 or something like that, and I think this, you know, the circuit diagram calls for a 630. I got some 530s. They're good, I think, for like 100 volts or so, maybe more or less, plus minus, and I don't know, maybe 10 amps for the tiny ones. So we'll see. You know, I'll get it on the that supply there because that goes up to at least 60 volts. So we'll see. I don't know. Because the typical Class E circuit that I used before, I think it was like 35 to 40 volts max, and then it would kill the MOSFET. For some reason, I'm not quite sure. Maybe some extra protection for the MOSFET. Might have to do with spikes coming from the secondary, or yeah, the primary coil. I don't know. And I'll have to try messing around with the primary. As for the circuit diagram, it's calling for a looser primary coupling. I'd have to read more into that. And first thing I got to get this off because this was a part of the kit that I bought before. It's that one over there. It was a kit, and then I actually built a circuit pretty much like the kit that I can play with, which was this guy right here. You know, kind of just to play with it and see what I could do with it. And then I saw this one, which was like an upgraded version to where it has feedback and whatnot, so that, you know, as you're drawing arcs or whatever, you're getting anywhere near this. Theoretically, the feedback circuitry from the coil should keep it in resonance. That's the idea. I don't know. We'll see. I'll play with this some more tomorrow. Anyway, catch you guys later. Cheers.